You ever walk into a room and it just feels right? Like a concert hall where every single note is just perfect? Or a restaurant where you can actually hear your friends talk without yelling? Well, guess what? That's not an accident. It's not magic either. There's a science to it, a secret geometry that dictates how a room sounds. And today, we're going to pull back the curtain on those rules.
Oh, we have all been there. You know, that conference room where everything echoes like you're in a canyon, or that super stylish cafe that's so loud it's just impossible to think. You might blame the noisy people, but a lot of the time, the real problem, it's the shape of the room itself.
Yep, that's the big secret. The actual architecture, the angles, the curves, the dimensions of a space is either your best friend or your worst enemy when it comes to sound. So let's get into it and figure out exactly why.
All right, here's our game plan. First, we need to learn the language of sound, so we'll talk decibels. Then we are going on a tour of room shapes, the good, the bad, and the truly awful. After that, we'll get into the golden rules of acoustic design, and finally, we'll put it all together so you can start designing for your own ears. Okay, before we can even begin to talk about shapes, we have to have a way to measure what we're hearing. And for that, we need to get comfortable with the decibel. So, the decibel, or dB for short, that's our yardstick for volume. But here's the tricky part. Unlike a foot or a gallon, a decibel isn't a fixed amount. It's really a ratio, a way of comparing one sound pressure level to another. It's all relative. So how small of a change can our ears actually pick up on? Well, a 3 decibel change is right about the threshold. It's the smallest difference in volume that most people can reliably notice. Anything less than that, you probably wouldn't even register it.
Now, what about a bigger jump? This is where it gets really interesting. A 10 decibel increase doesn't just sound a little bit louder. To our brains, it sounds twice as loud. It's what's called a logarithmic scale, so the numbers can be a little misleading if you're not used to them.
But here's the thing. Loudness isn't just a number on a meter. Check out this story. There was a DJ in a mall playing music at 80 decibels, and people were constantly complaining. Right nearby, there was a big water fountain making noise at 85 decibels, and everyone loved it. It just goes to show you that how we perceive sound is super subjective. The type of sound matters just as much, if not more, than the pure volume. Okay, now that we've got the lingo down, let's get to the main event, the shapes themselves. We're going to go on a little tour of room geometry, and we're starting with the absolute worst of the worst. Topping our ugly list, we have the sphere and the cube. A perfect sphere is literally the worst possible shape for sound. Why? Because every single surface focuses sound waves to one single intense point in the center. Now, we don't build a lot of spherical rooms, so in the real world, the cube is the worst usable shape. With its height, width, and depth all the same, you get these huge echoes and a chaotic jumble of low frequencies. It's just a mess.
And you're going to see a pattern here with other bad shapes. A cylinder? Well, it's got those same inward-curving concave walls that act like an acoustic magnifying glass focusing sound toward the middle. And a dome? Oh man, a dome has all the problems of a sphere, but it focuses all that sonic energy right down on top of your head from the ceiling. They might look impressive, but trust me, they're an acoustic nightmare.
All right, let's talk about the room that most of us are probably in right now. The good old rectangle, or the shoebox room. Its number one enemy is something called flutter echo. This is what happens when a sound gets trapped between two hard parallel walls. It just bounces back and forth, like a pinball. You know that weird zinging sound when you clap your hands in an empty hallway? That's flutter echo. So we've seen a whole bunch of problem shapes, but what's the fix? Now we get to the good stuff, the solutions. Let's dig into the golden rules that acoustic designers use to make a space sound amazing. First up is a concept called room modes. You can think of these as the natural, low-frequency resonances of a room, kind of like its deep, humming voice. Now, the goal isn't to eliminate them. The goal is to have a lot of them and to have them spread out evenly. When you get that right, you get that pleasant, warm bass sound instead of having some spots that are super boomy and other spots that are totally dead. So, where do these modes come from? They're formed by low-frequency sound waves bouncing around the room in 3 main ways. You've got axial modes, which bounce between 2 parallel surfaces, like the floor and the ceiling. Then there are tangential modes, bouncing off 4 surfaces. And finally, the most complex ones are oblique modes, which hit all 6 surfaces of the room. So how do we control all these modes? It is all about the ratios. The relationship between the room's height, width, and depth is everything. An ideal ratio, like the one you see here, makes sure all those resonant frequencies are spread out nice and even. A cube, with its 1:1:1 ratio, is just awful, because all the modes pile up on the same frequencies, creating huge peaks and valleys in the bass response.
Let's circle back to curves for a second. We talked about how domes and cylinders are bad news, and this image shows you exactly why. Those concave, inward curving surfaces act like a lens for sound. They take all that reflection energy and focus it into one small area, creating what we call an acoustic hotspot, where things are way too loud and completely garbled.
And this brings us to maybe the single most important rule in all of acoustics. It's super simple. Concave surfaces, the ones that curve inward, are bad. They focus sound. But convex surfaces, the ones that curve outward, are your absolute best friend. They scatter or diffuse sound energy evenly all around the room. And that is exactly what you want for a clear, natural, and pleasant sound.
And last but not least, let's talk about symmetry. For any space that's designed for an audience, like a theater or a lecture hall, having a symmetrical layout is a massive advantage. When the left side of the room is a mirror image of the right side, it becomes so much easier and cheaper to design a sound system that gives every single person in the room a great listening experience.
Okay, we have covered a ton of ground, from decibels to room modes to curves. So now, let's bring it all home and boil it down into a simple checklist you can use to size up any room you walk into.
Here we go, your cheat sheet. Number 1, stay away from acoustically toxic shapes like perfect cubes and domes. Number 2, remember that symmetry is your friend. It leads to predictable, even sound. 3, embrace high ceilings. More volume almost always helps because it gives sound waves more space to fade away naturally. And finally, number 4, do whatever you can to break up hard parallel walls. Use furniture, bookshelves, art, acoustic panels, anything to stop that nasty flutter echo.
So, here's my challenge to you. The next time you walk into any room, don't just look around. Listen to it. Is it a perfect rectangle? Does it have a curved wall? Are the ceilings high? Now that you know the hidden rules of acoustic geometry, I promise you are never going to hear a room in the same way again.